All right, this is station 10, which is layers of the atmosphere. The troposphere is the bottommost layer. This is where we live. It stretches up to about 10 kilometers. It is the lowest region of the atmosphere. About 80% of the air in our atmosphere is contained in this region. Clouds form here, weather happens here. It's warmest at the bottom, but as you go higher, as you reach the 10-kilometer limit, it gets colder, which is why you can be in a warm climate, like this picture of Washington with spring flowers in the foreground, and you see Mount Rainier in the background with snow on top, because the higher you go, the colder it gets. The next layer up is the stratosphere. This is where the ozone layer is, which absorbs most of the ultraviolet radiation, the UVB. Some of the UVA still gets through, which is why we need to wear sunscreen. As you move up, it actually gets warmer because of all that radiation that's being absorbed. Jet airplanes fly in the stratosphere, and weather balloons. If you've ever seen those pictures of students launching weather balloons and getting pictures of the curvature of the Earth, that's all happening in the stratosphere. Is very dry up in the stratosphere, and it contains very little water, and that's why when you're in an airplane, the airplane needs to be sealed and pressurized in order for you to be up there. The mesosphere is 50 kilometers to about 85 kilometers. It is the coldest layer of the atmosphere, and this is the atmosphere where meteorites vaporize or burn up. So if you've ever seen a shooting star, that is breaking up in the mesosphere. The thermosphere stretches up to about 1,000 kilometers. There is intense solar radiation in this area, and the temperature sits around 200 degrees Celsius. This region has a lot of satellites, and it has the International Space Station orbiting. X-rays and ultraviolet rays are absorbed in this layer, and the aurora, which are the northern and the southern lights, are caused by the magnetic field of the Earth blocking solar radiation and producing light, and that happens in the thermosphere. There is still a little bit of atmosphere up here, so when they're designing a satellite, they need to account for the drag on the little bit of molecules that they bump into while they're up here. Otherwise, the satellite will slow down and will fall out of orbit. The exosphere is the highest layer. It is over 1,000 kilometers and up. There is no clear upper boundary because this region is very similar to space, but again, there is still a little bit of atmosphere here, so when there are satellites and rockets that are going through this layer, they need to have the drag taken into account whenever they're traveling through this area. Otherwise, they are affected by the molecules bumping into the rocket. The atmosphere is impacting the hydrosphere because the troposphere is where the water cycle happens. So when the water goes up into the atmosphere and becomes clouds, it gets dumped back down on the land, which fills up rivers and lakes and ponds. It can also dry out rivers and lakes and ponds. It causes erosion, like this picture from Hurricane Matthew. And in terms of the biosphere, animals depend upon the air in the atmosphere to breathe. They depend upon the water in the atmosphere to get a drink of water. And they depend upon the climate, the temperature, being reasonable for their needs. All right, so the water cycle. So here is a water cycle. I'm going to show a couple different slides, but basically what's happening is the sun is the main source of energy for the water cycle. The sun heats up the surface of the Earth, 71% of which is made up of water, and it causes the water to evaporate. The evaporated water rises. As it gets to the upper part of the atmosphere, it condenses. It turns from a gas back into a liquid, but that liquid is in cloud formation, and it stays in cloud formation until enough of it builds up that it can rain down and it becomes precipitation. Once it's precipitation, then it can take on a bunch of different forms. If it's warm enough, it can become rain. If it's too cold for rain, then it can be a couple different forms. There's sleet, there's freezing rain, there's hail, and there's snow. Now, we occasionally will get hail here. We get marble-size hail, but hail could be as big as golf balls, and it can be extremely destructive because it's coming down like little, basically marbles or golf balls or that, and it can destroy car windows and ding your roof and things like that. It really depends upon the temperature of the area as to whether or not the rain is, or the precipitation is going to come down as rain or sleet or freezing rain or hail or snow. The reservoir that the water runs into, whenever the waters run down, even in snow formation, it eventually melts and runs down into a reservoir. It always runs to the lowest point. And those lowest points are places like ponds and lakes and streams and rivers and natural springs and oceans. Again, 71% of the earth is covered in water, and all of that water is rain that has run down into the lowest point. And then it recycles. It gets heated back up by the sun, goes back up into the atmosphere, and then comes back down. The reason that it's cooler when there's clouds out is because the clouds are blocking a lot of the solar radiation from getting in. They're blocking that thermal energy from getting in, they're blocking the heat from getting in, and they're keeping it from warming up the surface of the earth. When the surface of the earth isn't warmed as much, then it doesn't get as hot out. So on overcast days, the temperature is going to be a lot lower. The reason that it rains more so here in Florida in the summer than it does in the wintertime is because the sun is the main source of energy. So in the summertime, it's a lot hotter here. Water evaporates much quicker, and therefore water's building up to capacity in the atmosphere a lot quicker, and we're getting rain every single day. And last question, once again, the determining factor for whether rain will come down as rain or snow or sleet or hail is the temperature of the environment. All right, now weather and climate. The main difference between weather and climate is the fact that weather is measured over short-term periods like weeks, and climate is measured over long periods of time. You're looking for trends and patterns. So when you talk about the weather of Orlando, you're talking about what it's going to do over the next week. That's why when you watch the news, it never shows further than about 7 or 8 days out. When you talk about climate, you look at a chart like this that shows patterns and trends. What is it like in January in Orlando? What is it like in February in Orlando? And what's the temperature? What's the high temperature, the low temperature? How much rain does it usually get? That's what the climate is. It's a comparison over time of averages. You know, they take the last 30 years worth of averages and they say this is the typical weather for the month of January in Orlando. That's climate. The weather for a week going out, whether it's going to rain or it's going to be hot and sunny or it's going to be overcast or whatever, that's weather. So again, the main difference is short time versus long time. For weather, you're looking at a day or a week ahead of time, and it's a forecast. For climate, you're reporting averages, so you're looking over 30-year time periods, and it's a much longer time period. The climate of Central Florida, here's a graphic of the climate of Central Florida. Those of you that have lived here, you know it's a subtropical climate. It's going to be really hot for long periods of time, usually from about March until September. It is warm. In the summertime, it's really warm. There's a lot of moisture in the summertime, and then in the wintertime, we're not as cold as other places. To compare that, someplace like Seattle, their high temperature in the summertime is going to be in the 80s, which would be awesome for us if that were the case. But at the same time, they turn around and they get much colder in the wintertime. They drop down into the upper 40s. And we don't normally do that. They stay colder for longer periods of time. As far as rainfall in Seattle, we get a lot of rain in the summertime. Seattle gets most of their rain in the fall, in the wintertime. So there's November, December, January, February. That's when they get most of their rain. And then the actions of human beings. They've been tracking global carbon dioxide, the amount of carbon dioxide in the atmosphere, and they've been comparing it, as you can see in this graph, to the temperature. And you can see how as carbon dioxide increases, so does the global temperature. And this is the main piece of evidence for the global warming, which says that human beings are negatively impacting the ecosystem, the climate of the Earth. So you've got this slide here that talks about how there are just 5 companies that pump 12.5% of the carbon pollution into the atmosphere. And you can see how most of them are gas companies. Your carbon footprint is the amount of carbon that you use In other words, the food that you eat, how much carbon was required to produce that food, the kind of vehicle that you get around in, how much carbon is it producing on an annual basis, the house that you live in, what kind of carbon was necessary to build the house, all of the things that you enjoy in your life, how much carbon are you producing to enjoy those things? And if you look at a graphic like this, you can see how people in the United States are well overproducing other countries in the amount of carbon that we are producing. So there is a global initiative to reduce your carbon footprint. In other words, as an individual, you can do things to reduce the amount of carbon that you're utilizing. And if enough of us got together, then it would make a global impact.